Next question. When two sigma bonds on a carbon, say on the same carbon, cleaves, the following chargeless carbon species will be formed with the 6 electron in the valence shell. So, we have given the question that two sigma bonds on the same carbon is cleaving, and at the end we will get a chargeless carbon species with 6 electrons in the valence shell. Option A, it is benzene. Option B, it is carbene. And option C, it is nitrene. And option D, it is both benzene and carbene. So here we can see it is actually the answer is carbene, because in carbene, when the chloroform is reacted with NaOH, the first hydrogen will cleave, and after that one chlorine atom will also cleave, and at the end we will get the carbene structure. In the carbene structure, the valence electrons in the carbon will be 6, because 2 electrons will always present, and four electrons will later present on the carbon atom. So the answer here is carbene, because the two species are cleaving from the same carbon atom, and at the end the intermediate formed will be chargeless, and the number of valence electron will be 6. But if we case the benzene only, the triple bond is formed between 2 carbon atom, and a 2 carbon atom will lose each particle from it. So benzene is not the right answer. And in the case of nitrene, it is not a carbon species. In the question, it is asked, it is a carbon species. So the answer will be carbene only. So both the two sigma bonds is cleaving in from the same carbon, and it is a chargeless species, and it also have 6 valence electrons. So our answer will be B, carbene only. Next question. Given below are two statements. One is labeled as assertion and other is labeled as reason. Assertion statement is cyclopropane is more prone to undergo ring opening reaction than cyclobutane. Reason, according to biostrain theory, cyclobutane is more highly strained than cyclopropane. So, in the light of the above statement, choose the correct answer from the options given below. Option A, both assertion and reason are true, and reason is the correct explanation of assertion. And option B, both assertion and reason are true, but reason is not the correct explanation of assertion. And C, assertion is true, but reason is false. Option D, assertion is false, but reason is true. So when we do the calculation of calculating the strain energy using the biostrain theory, we will get that the strain energy of cyclopropane is 27.6 and the cyclobutane is 26.6. And it is said that cyclopropane is, first in the assertion statement, it is said that cyclopropane is more prone to undergo ring opening reaction than cyclobutane. That is a true statement, because cyclopropane have a very high strain compared to that of cyclobutane. So it will undergo ring opening reaction very easily. So assertion statement is true. And the reason statement says that according to biostrain theory, cyclobutane is more highly strained than cyclopropane. That is false. According to biostrain theory, cyclobutane have a strain energy of 26.4. That is less than compared to that of cyclopropane that have a strain energy of 27.6. So statement B is that is reason is false. So our correct answer will be A is true. That is assertion is true, but reason is false. That is option C is the correct answer. Next question. Given below are two statements. Statement 1, E2 reaction follows second order kinetics and not accompanied by the rearrangement. And statement 2, E2 reactions shows large hydrogen isotope shift. So in the light of the above statement, choose the correct answer from the options given below. Option A, both statements are true. Option B, both statements are false. And C, statement 1 is true, but statement 2 is false. And D, statement 1 is false, but statement 2 is true. So here we know that E2 reaction, it is said E2 because it is a second order kinetic reaction. So statement 1 is always true, and E2 reaction show large hydrogen isotope effect. That is also true. That is a theoretical statement. So both statement 1 and statement 2 are true in this question. So our correct option will be option A. Next question. the absolute configuration, that is R and S configuration of the following molecule. We want to predict what will be the R and S configuration of this molecule given here. So option A, 2R, 3R, 4R, B, 2R, 3S, 4R, and C, 2S, 3R, 4R, and D, 2R, 3R, and 4S. So when we do the calculation, first we can see the second position. So according to CIP rule, we want to first give preference to each branch. So in the second position, the OH will have the highest preference. So it will have a preference of A. And in the CHO group, here we can consider oxygen as two singly bonded oxygen that is connected to the carbon atom. So it will have a preference of B, and the carbon branch will have a preference of C, and the hydrogen. One hydrogen will also be connected to that second carbon, and that hydrogen will be in the wedge position if OH is in the, that hydrogen will be in the dash position if the that hydrogen will be in the wedge position if that hydroxyl is present in the dash position. So here we can see that when we are doing the rotation from A to B to C, here we can see the rotation will be actually in anti-clockwise direction. But here hydrogen is in the wedge position. That is, low priority group is in the wedge position. That hydrogen have a priority of D, that is 4. So hydrogen is in the wedge position. So we have to take the opposite of the rotation that we have given. That is, if we first got anti-clockwise one, so R will be the clockwise one will be the right answer. So at second position, the rotation will be 2R. So option, we can exclude the option C, that is 2S, we can exclude. And in the third position, first we want to give the priority. So OH will have the higher priority, and it is also in the wedge position. So OH will have the highest priority. And next, B will have the B, that is the group that is at the right portion. At the right portion will have the second priority, and C, that is the left portion, will have the third priority. So when we do the rotation, it will be clockwise rotation. So the configuration at the third position will be R. So we will get 3R. So we cannot exclude any option. That is, all other options have 3. In the third position, it is given that R will be the absolute rotation. And next, in the fourth position, we can assign the rotation. Here, the OH is in the dash position, but it will have a highest priority number of 1. And the second option will be, second priority is given to the carbon chain in the right position. So because it have a longer chain, so the priority will be 2 for the right chain. And third priority is given to the left carbon chain, and fourth priority is given to the hydrogen that is in the wedge position. So when we do the rotation, we will get it as anti-clockwise, but here the highest priority group is in the dash position, so it cannot be assumed that it is the S rotation here. So we have to take the opposite of the S rotation, that is R rotation. So in the fourth position, the rotation will be R. So all the 3 position, the rotation will be R. So correct option will be 2R, 3R, and 4R. So our answer will be option A, 2R, 3R, and 4R. Next question, match the list 1 with the list 2. So in the list 1, the sum of the molecular structure is given here. We want to predict whether it is aromatic, anti-aromatic, homoaromatic, or non-aromatic, and the options are also given here. In the first A case, we know that it is a 8-membered ring. Membered ring, and there is a 1 sp3 carbon, but rest of the structure will contribute to aromatic structure. But 1 sp3 hybridized carbon is present in between the ring. So when 1 sp3 carbon is present in the aromatic structure, we will call it as homoaromatic, so that that sp3 carbon will exist in the not in the plane, it will exist above the plane, and rest of the carbons will participate in aromatic character. So we know that the structure A is homoaromatic in nature. So A will be 3. So A will be 3. A structure is homoaromatic in nature. And next, when we see the B structure, here it is a cation. So all the 5 atoms here is sp2 hybridized, all is in the same plane. And when we count the number of pi electron, there are 2 pi bonds present. So the number of pi electrons will be 4. That is 4 and pi electrons is present. So all the carbons is planar and the 4 pi electrons are present here. So B structure is anti-aromatic in nature. So B will be 2. And when we see the C structure, we can say that it is an anion. So there is all the carbon atoms is in the same plane, or all the carbon atoms are in the same plane. And when we count the number of pi electron, it will be 1, 2, 3, 4, 5, 6. 6 pi electrons are present, and all the carbon atoms are sp2 hybridized. So the option C is aromatic in nature. So C will be 1. And option D, when we see that only 4 pi electrons is present and 1 carbon is sp3 hybridized. So it will be non-aromatic in nature, because rather than removing 1 electron, one electron in order to form a cation, which is anti-aromatic, it will exist as non-aromatic structure. That is, D structure will be non-aromatic, that is 4. So when we match all this, we will get option D as the answer, that is A3, B2, C1 and D4. Next question. Given below are 2 statements. The statement 1, the rate of an SN1 reaction depends on both the carbon skeleton and the nucleophile. And statement 2, the rate of SN2 reaction depend on the carbon skeleton, the leaving group and the nucleophile. In the light of the above statement, choose the correct answer from the options given below. Option A, both statements are true. B, both statements are false. C, statement 1 is true, 2 is false. And D, statement 1 is false, but statement 2 is true. So when we see the rate of SN1 reaction, the rate of SN1 reaction only depend upon the concentration of the carbon skeleton. So first statement is false. It will not depend upon both the carbon skeleton and the nucleophile. And when we see the second statement, the rate of SN2 reaction depend upon the carbon skeleton, leaving group and the nucleophile. That is true. That is it will depend upon the concentration of the carbon skeleton and also the concentration of nucleophile, and also the leaving ability of the leaving group also have some role in determining the rate of the SN2 reaction. So that statement is true. So our correct answer will be statement 1 is false but statement 2 is true. So correct option will be option D for this question. Next question. Which of the following trends of nucleophilicity is not correct? Option A, ETO minus greater than OH minus, and B, NH3 greater than OH, H2O, and C, phenoxide PHO minus greater than OH minus, and D, I minus greater than Br minus, E, CH3 acetate greater than CH3 CH2O minus. Choose the correct answer from the options given below. Option A and C only, B, A and E only, C, B and D only, and D, C and E only. So here we can see in the structure, the nucleophilicity is that species, that is all the species contain negative charge. How easily that species can accept a positively charged species, that is known as the nucleophilicity. So here we know that alcohol is always less acidic than water. So it do not have that much ability to give a proton because of the high nucleophilicity of ET or O minus. So that statement, that is true. That is always the ET O minus ion will have more nucleophilicity than OH minus. And next, NH3 and H2O, we know that oxygen is more electronegative. So it will try to pull that electrons towards itself. So that statement is also true. That is, NH3 will be more nucleophilic. That is, nitrogen will easily give its lone pair rather than oxygen. So that statement is also true. But here in the case of phenoxide and a hydroxide ion, we know that phenoxide ion is more resonance stabilized because of the various resonance structures. So that electron will not be easily available from the phenoxide. So that statement is false. Hydroxide will be more nucleophilic than phenoxide ion, and in the case of I minus and Br minus, we know that I minus will be more nucleophilic because it will give its electron pair very easily when compared to that of Br minus. And in the case of acetate, we know that electron pair will be resonance stabilized from between these two oxygen, so that electron cannot be, it is not easily accessible, so it is also resonance stabilized when compared to that of CH3 CH2O minus, so that electron is not available in the case of acetate. So A statement is also wrong, and in the question we have to find which are the false statements. So C and E are the false statements here, so correct option will be option D, C and E only. Next question. There is a chemical reaction scheme is given here. We want to predict what will be the major product for the following reaction. So here in the benzene ring is given, and at the one position an aldehyde group is present, and para to that aldehyde group one ester group is also present, and this molecule is reduced using sodium borohydride in methanol. So we want to predict what will be the right answer. So sodium borohydride is used to mainly convert aldehyde to alcohol. Only aldehydes, it will selectively reduce aldehydes to alcohol. It will not touch any other group, that is acidic group or ester group present in the molecule. So only aldehyde will get converted into alcohol. So ester will not get reduced while sodium borohydride is the reducing agent. So the correct answer will be option C, that is only aldehyde is getting converted into alcohol. There is no change in the ester group. Ester group will not undergo reduction. So option C, that is only aldehyde group is converted to alcohol, will be the right answer for this question. Next, the reaction between methyl bromide and sodium tertiary butoxide delivers what product? Option A, tertiary butyl methyl ether, B, tertiary butyl alcohol, C, dimethyl ether, and D, di-tertiary butyl ether. So when methyl bromide react with sodium tertiary butoxide, it is an SN2 reaction. So it is a nucleophilic reaction. So we will get this product, that is tertiary butyl methyl ether, that is C, CH3 thrice O CH3. That is option A, tertiary butyl methyl ether will be the right answer.